All right, so download this new project about sound. It's the first half of our study of waves that we'll do during the rest of the semester, and then we will finish, or we'll start the new semester with studying light waves. And as I said before, this image of sound waves shows us a couple things. The taller the wave, the louder the sound is. We call that the amplitude. And then the distance between waves is showing how fast it's vibrating. That's known as the wavelength. And the vibration speed is called the frequency. How fast it's vibrating per second usually is its frequency. And so these wavelengths vary a lot. For instance, with light, the distance between waves in what we think of as light, visible light, is microscopic, and it's measured in like billionths of a meter, nanometers it's called. But there's another form of light, which you've all heard of, radio waves, actually light. Um, and the distance between those peaks from one peak to another, the wavelength in a radio wave, is like 100 yards. It's really big wavelength, vibrating much more slowly than what we see as visible light. We can go the other way too and talk about X-rays, which are a type of light, and those are vibrating even faster than visible light that itself has microscopic waves. So let's come back to sound waves. And I just want to show you a little image here. This is from a popular recording program. Can you guys see that okay?
Yeah.
Yeah.
Okay, so there's this program called Ableton Live, which is great for creating music, whether it's electronic music or acoustic music. And when you record something, you end up seeing the sounds like this. So you can tell that a sound started right here, and it kind of carried on for a little while, and then a new sound started over here. This might be another sound, a quieter one that started at that point and kind of overlaps with this other one. So visualizing waves like we see on the front cover of our project is very common in the music industry to demonstrate the waves like this. However, it's not really what a sound wave looks like with it going up and down like this. Instead, if we go down to the next page just for a second, it's more like this is really what's happening with a sound wave. The vibration is going back and forth instead of up and down like we see on water. So there's a couple different kinds of waves. And I'm really happy to be talking about sound for a couple of weeks because I love music and I love to play music. So part of what we're going to look at is the relationship between different parts of a wave, the cause and the effect. When we change one part of a wave, specifically the wavelength, the distance between waves, it has the effect of also changing how fast those waves are moving, their frequency. And we hear that in sound as a change in pitch, as we'll talk about coming up. So at the top of each page, you're going to see this header as a reminder that wave properties include frequency, wavelength, and amplitude. So I've already introduced those. Frequency is how fast the vibrations are occurring, how fast the waves move by, usually it measured in waves per second, or cycles per second, or oscillations per second. And then wavelength is the distance between one peak and another. We looked at that over here, the wavelength between these two. We could measure that distance between one peak and another. A horizontal measurement is the wavelength. And then there's the amplitude, which is how tall this wave is, which for sound is going to tell us how loud it is. On the other hand, the wavelength for sound is going to tell us the pitch, if it's a high pitch or a low pitch. So the big question, what are the properties of a wave and how are those properties mathematically related? How can we connect these properties to one another? And we're going to see that as we move through this project. Hey, is there a volunteer to read this first paragraph for us? Some New Year's extra credit for somebody?
I'll read it.
All right, who's that?
Vanessa.
All right, good job, Vanessa. Not your first time, huh?
No.
All right. Thanks for stepping up. Go ahead.
Okay. The image on the front cover shows an artistic representation of the sound waves from a recording. We can tell that the taller sections are louder than the shorter sections. Although in this picture it is difficult to recognize which sounds are higher or lower pitched, we can also see how long each sound lasted by noticing where the waves returned to the center line. Do you think you could convert this image into a series of sounds?
Nice job. Yeah. And then we could also record your dog barking in the background and see what its sound waves look like, huh?
Yes.
All right. Thanks, Vanessa. All right, so what I'm going to do for the next couple of minutes is ask you guys to draw some sound waves, 3 of them, as you can see on the assignment, on the project. Here's an example of what these sound waves should look like. So use this as your guide. You just use parentheses. You just write a bunch of parentheses and separate them at different distances from one another. But to make a good sound wave, you have to clump some of them close together and you have to spread other ones apart. Okay? Instead of going up and down, like what we think of as a wave on water going up and down, we have these regions where the air molecules are squeezed together and other regions where they're spread apart. And we call this the zone of compression, where they're squeezed together, kind of like the peak of a wave. And then we call this, where they're spread apart, the zone of rarefaction, kind of like the trough of a wave that we would see in water. In fact, maybe I could draw something like that. If this was a water wave, which it's not, it might be something like this, right? But this is a different kind of wave that we see in water. This is the kind of wave that we see with light, but it's different with sound. This one is vibrating up and down. The water wave that I drew goes up and down, but the sound wave goes back and forth. It's these vibrations that travel through the air, and the air molecules literally get squeezed together in the zone of compression, and they get stretched apart in the zone of rarefaction. Maybe that's called rarefaction because the molecules become more rare. They're spread apart there. So you're going to make a practice sound wave across here. Try to show zones of compression and zones of rarefaction. Then you're going to do 2 more, one quiet and one loud. And all you need to do for those is change the font size. If you change the font size, you'll be able to show quiet and loud sections. So again, the loud part is when it's really tall, and the quiet part is when it's short. So you can see, for example, this wave is much louder than the wave just before it, right? This sound was quiet, this one was loud. So you just change the font size to make a loud wave and a quiet wave. First, make a practice wave. For all 3 of them, you should have your parentheses spread out and then clumped together. I think when I did this, I just put in parentheses and then like 5 spaces, another parentheses, 5 more spaces, another parentheses, 5 more spaces. Then I just did 5 parentheses in a row to show them compressed in the zone of compression. And then I started putting spaces between them again.
Mr.
So
Fairley,
use the space bar and the parentheses. Yeah.
Mr. Fairley, does
Yeah.
it have to be groups of like 3 and then groups of 5?
No, it doesn't have to be.
Okay.
But I should be able to see zones of compression and zones of rarefaction. And I should be able to see on the quiet and loud that the loud one has taller and the quiet one has shorter, right? So just take a minute to finish that. And then give me a thumbs up when you're done with that part. How's it going out there? Anybody have questions?
Should you keep the same consistent space between all of the parentheses? Like if you do different spaces in between?
I think that's going to be hard when you do a quiet and a loud one, because when you switch to a bigger font here, it's going to take more space to cover the page. I mean, each letter, each parentheses will take more space. So you won't be able to put the same number of waves for the loud one as you will for the quiet one. So I think that will be
Okay, thank
difficult.
you.
And this is the first time we're doing it, so it's pretty open just to kind of get an idea. I kind of think consistency across a single wave is important though. So like I've been consistent all the way across here, always doing 3 parentheses separated by 5 spaces each, and then a group of 5 parentheses with no spaces, 3 more separated by 5 spaces each, like that. I was consistent all the way across here. So you should do that within any single wave that you're drawing, be consistent there. But you don't have to be consistent between different waves. Let's see, how are we doing? Gus is done. Thanks, Gus, for letting me know. Thanks, Sam. All right, Andres. And look at that. We've already finished the first 2 pages on this. As usual, some of this we're going to do together in class, and some of it you're going to have to do on your own time. I will give you some class time for some of it, but other parts might be considered homework, so we can get it done before the semester ends. All right, and Quetzal's done. Excellent. So I'm going to go ahead and move on. And it takes us to this page, page 3. What is a wave? And the purpose of this lesson is to begin to understand waves and their characteristics. We will begin with exploring sound and some of the surprising ways that people make sound waves. So what we're going to do is we're going to see these guys that play a song using rubber chickens. And I've noticed that it's kind of hard for a single computer to both send a video and an audio through these programs. So what I'm going to do is play the audio through a different computer, hoping that it will be picked up by this computer while we watch the video on this computer. So the video and the audio might not quite match up, but the whole point is just to observe what these guys are doing. And I'd like you to write 3 things that you like about it, what you see and what you hear. Write 3 things about it, and then we'll come back. It's only about a minute long. So I believe I have it all ready to go right here. And again, I don't know how well I'm going to get the timing on this, but I'm going to do my best. Here we go. Oh, I want to mute this computer. Yeah. Crazy, right? So I don't know how well that worked for you. Hopefully you were able to at least get an idea of what's going on, that these guys were using rubber chickens to play music. I thought it was pretty amazing how accurate they were just by playing a rubber chicken as if it was a musical instrument. I wish they had like an explanation of how they did that. But inside the neck of the rubber chicken is a device that vibrates, and so that's making the sound. And apparently they are able to manipulate the pitch of it as well as the volume by the way they're squeezing the chicken. It might even be that they cut some holes in it, so they're playing it as if it was kind of like a clarinet. I don't know. But I'd like you to write 3 things about what you saw. Pick one of them that involved sound and hearing, and write a question about it that we could investigate scientifically. I just want you to think of taking a scientific approach to our study of sound um, based on what we watched. So I might have given you some hints in my comments about it, actually. So take a minute to write down 3 things about it, and then write a scientific question. And then give me a thumbs up when you're ready to move on. And perhaps I will play that again. When it's over, that's when we'll move on to the next thing. Well, uh, I don't know about you, but I think that's going to give me an earworm. It's going to be stuck in my head for a while, um, particularly since I also showed it to my class yesterday and talked about it with other teachers and stuff. So anyway, I'm going to move on. I'm just curious, could you guys hear and see the video? I want to know if my approach to playing the sound through a different speaker is working. Anybody?
It was
Let
a
me
little
know.
bit
I couldn't
distorted.
hear it.
Kind of distorted, yeah. Well, it's kind of a weird sound anyway, but
Yeah, I could hear it the first time.
the second time I didn't play it through the separate speaker,
Okay.
and it worked better the first time, huh?
Yeah, because you could actually
Okay.
hear it.
Yeah, that's good to know. So, okay, so now I don't know if you read the note that I sent out before class. It said it might be fun if you grab a straw and some scissors, and basically you can make a kazoo, a very simple musical instrument, out of a straw. So first you flatten the straw. Then you cut one end of it into a V so it looks like a bird's beak. And then you start blowing on it. And you kind of have to experiment a little bit in order to get sounds out of your strazoo. Now, maybe you don't have a straw at home, so I have one ready to go, and I'm going to demonstrate all of this. And then once we get it playing, we're going to shorten it bit by bit. We're going to cut off the end and shorten it and listen to how the sounds change. And before we begin, I would like you to think about what you expect to have happen as I make the straw shorter. How do you think that's going to change the sound that it creates? So I'm going to turn on my camera now. And keep in mind that I'm a percussionist, not a wind player. So I don't know how well this is going to sound. Let's see. Can you see this thing? All right. There's my strazoo. And I've cut the end of it to a V point, and it has basically a split in there, which means that the two ends are going to vibrate against each other when I blow through it. And that's what's going to make the sound. It's very much like a reed instrument, like a clarinet or a saxophone or an oboe. So here's my straw. It's this long now. Now let's see what if I can make it sound. Okay, so there's the sound of it. What do you think is going to happen when I cut off a couple centimeters from the end? How will that change the sound? All right, here we go. I cut it shorter. What do you think is going to happen? Were you right? Notice that the pitch went up. Cut it off even shorter. Sounds like I'm at a New Year's party, huh? Oh boy, it's hard to get it vibrating at this one. It's so short. Nope, I can't do it. But hopefully you got the idea that as we cut it shorter, its pitch went up, huh? So, let's see. Here's a word bank for you to fill in. First of all, I want you to use the proper word for volume, which is the amplitude of the wave. Did it get, and once you use that, you might have to say if it's louder or softer as well. And then, sorry, there's a V in front there. There shouldn't be. That should just say pitch. Did it get higher or lower? So as the straw gets shorter, what happened Did the amplitude change? Did the pitch change? Did the vibrations change? Well, they must have if those things changed. As I blew harder or softer, what should happen? What do you think? As you blow harder, should that change the pitch or should that change the volume, the amplitude? And then how does that kazoo make sound? Again, use the word bank there. And then finally, predict whether you think a trumpet or a tuba would have a higher pitch. Now, these are both brass instruments, and with the kazoo, like I said, it would really fit into a reed family of instruments. So when we say a reed, we are literally talking about a reed. A reed is a plant that grows in a swampy area. And it used to be that they would cut these plants, dry them out, and take a little piece of kind of a really thin, imagine a thin piece of wood, and they put it in the mouthpiece of the instrument, of the clarinet or the oboe, at least its ancestor, or the saxophone, and that reed vibrates to make the sound. But with a tuba or a trumpet or a trombone, these guys, it's actually the person's lips that are making the vibration. And then that's projected through this long tube in a trumpet and an even longer tube in a tuba. And maybe that's why they call it a tuba, because it's a long tube. I don't know. But basically, because the tube is so long, they decided that it would work better if they wrap it up, coil it up in a loop or a couple of loops. Maybe you've seen that tuba called a sousaphone that a person wears around them. Like think of a marching band on the football field where there's this big, they literally are surrounded by their instrument wrapping around them. Another way to think about these horns is the old Swiss horn, which isn't wrapped up, and it's like 10 feet long. It's so long that they rest the end of it on the ground. So do you think the trumpet or the tuba would have a higher pitch? And then number 5, explain why you made that prediction. And then once again, I'd ask you to give me a thumbs up when you're done with that stuff and ready to move on. We'll be done with page 3. If you have any questions, please ask. Thanks, Kaylee. All right, Jose, thank you. Good job, Alejandro. All right, Lena, good job. Thanks, David. Okay, it looks like we're making good progress. We've finished 3 pages of this already. Good job, Kitsali. Now, basically, the next page is a half-page article about sound. And it's asking you to do 2 things: highlight the important text, and then answer the questions at the end. Okay? So we're going to do that. And I want to show you what's coming up. So the next several pages, I think 4 pages, are called A World of Sound. And basically, like I said, I love music, and I love music from around the world. and the different ways that people make music is just incredible to me. I love seeing the traditional approach to the music from different cultures. And I also love seeing the way we can combine music from different cultures. For instance, African music combined with jazz, or Indian music combined with electronica. I love that stuff. It's a amazing world of sound out there with all these incredible instruments that people use. And I also play a lot of these instruments. Some of them I play better than others, as you'll see in this video. So I made a video that you're going to watch, and while you're watching it, you need to be filling in these pages. So for instance, this instrument, as you'll see on the video, is called the balafon, and it's from Africa. And I'm going to play it a little bit, and I'm going to be talking about how it makes the different sounds. While I do that, you should be taking some notes. You should be making some observations. I'm also going to focus on some scientific questions like what is sound? And so you should answer these questions as you go. This whole video is divided into these segments. I think there's 12 of them. So this is segment 1. Segment 2, name this instrument, to say where it's from, make some observations, and then answer this question. I will give you a hint that I think I forgot to discuss that at the end of this segment. Instead, I put it at the beginning of the next one. All right, so we're going to see these different instruments from around the globe. I made this video over our holiday break. You can see there's some crazy stuff out there. Look how this one looks like a bow and arrow. Brazil. And as you go, you're going to answer questions. You're going to fill in this chart. You're going to name every instrument, describe where it's from. You might make some predictions ahead of time, right? So I think personally, and that's the end of that part, page 8. Personally, I think that it's too long to do this whole video in one class, especially because we already started, and especially because I'm also asking you to do this reading and answer these questions. So here's your assignment. Start with the reading and the answering these questions. You should finish that definitely today. We have, I think, another half hour of class, basically. Then I would like you to finish the first 2 pages of the video. The first half of the video I want you to do on your own. Okay? So when you get up to number 7, it looks like, then you're done. And then on Thursday, we'll talk about the second half of the video. Okay? Any questions? Everybody understand what they're supposed to do? Basically, you're supposed to finish page 4, page 5, and page 6 before Thursday. All right. Who's got questions? Well, if I didn't say it before, or maybe you weren't here when I did, I want to wish you all a happy new year. And let's really focus for these last couple of weeks of the semester. It's our last chance to get caught up on any missing work. And we still have some new work to do too, this project, right? So I'm waiting for some of you to turn in your project 3 about momentum. I know you worked on it, so I want you to get it done and turn it in. Basically, there's 3 options. 1, you finish the whole thing and you turn it in. You maximize your points that way. Your second option, don't turn it in. Don't do any more than we did in class, and you get 0. I would not recommend that option, but it is an option. Third, you turn in what you've done. Maybe you haven't done the parts that you were supposed to do alone, but you did do the parts with me in class, right? So you should at least get credit for that. So pick your option. I've got some people who've turned the whole thing in. I've got some people who've turned nothing in. There is a third option. At least turn in what you've done and get partial credit. Better than a 0, right? So you still have some time to do the rest of it yourself, but get some points, right? You got to get some points. Maybe you were absent one day in class and I've been making these recordings. Go back through the posts and find where there's a video that shows you how to do the different parts of the project if you were absent on those days. All right? So that's all I have for you today. It's great to see your names, even if I didn't see your faces. I heard some of your voices. Please do pages what, 4, 5, and 6, the reading and the first half of A World of Sound, okay? And that's what I'm going to leave you with, all right? So
Thank you.
thanks for being here.
Thanks, Fairley.
Yep, thanks for showing up. Do your work,
Thanks,
guys.
Fairley.
All
Thanks,
right.
Fairley.
Thank you, Fairley.
Let me know if you have questions.
Thanks, Fairley.
Bye.
See you, Fairley.
Adios. Have a good one.
Thanks, Fairley. Bye.
Auf Wiedersehen. Ciao. See you next time.
You need to say who you are. Mr. Fairley, this is Sylvia with Dylan. And
Hi.
hi, how are you, sir? Happy New Year. So I'm over here with Dylan and also with Patricio, with Pat. And they're,
Good.
so my question is, when is the last date for late work?
Let's see. What does the calendar look like?
Next week is the 15th. This week is Friday is the 8th and the
I'm
15th.
going to call it the 22nd is the last day for late work.
And are we able to submit stuff, all the missing assignments, like even from October, or do
Yeah.
we stick? Okay.
Absolutely. I will penalize a little bit for being so late, but my penalty is only 10%.
Oh,
So
okay.
they can still get 90% of the points.
Okay, perfect. Awesome. Okay,
Yeah.
so that's what we just needed to know, that so we can focus on that, since they're gonna be
Right.
coming this week to the building. Okay,
Yeah.
awesome. Thank you, sir.
Bye.
Bye. Okay.